All right, welcome back. We are now in 6.2, which is called sum and difference formulas. So as you see in the notes, we have pretty much 6 formulas, 2 a cosine, 2 a sine, and 2 a tangent. So we're going to walk through some examples. So we're going to look at this first example here. I want to find the exact value of cosine of 15 degrees. Now, when you're looking at this, what you're trying to do is you're trying to use numbers that are on the unit circle to make your life easy. And if you'll notice, 15 degrees is not on your unit circle. So what we need to do is we need to rewrite 15 in terms of numbers that are on the actual unit circle themselves. So I can look at 15 degrees and I can say, okay, well, I can do 60 minus 45. Because I have a 60 degrees and a 45 degrees, and that will give me 15 degrees because I want to make sure that I'm using one of my 6 formulas that I just used. So I'm going to go ahead and use that. Now, mind you, you can use anything as long as you get to the 15 degrees. So if you want to go completely around and do bigger numbers, you can do that. You are more than welcome to. We just need to force that 15 degrees. So this is our alpha. That is our beta. Now we're going to actually do the problem. So cosine of 15 degrees is the same thing as cosine of 60 minus 45. That turned into cosine of 60 times cosine of 45 plus sine of 60 times sine of 45. All right. Now we're straight back to the unit circle. So what is cosine of 60? Cosine of 60 is 1/2. What is cosine of 45? Square root of 2 over 2. What is sine of 60? That's the square root of 3 over 2. And what is the sine of 45? That again would be the square root of 2 over 2. So now, almost done with this. We're going to go ahead and clean this up. So 1/2 times the square root of 2 over 2 winds up being the square root of 2 all over 4. Plus the square root of 3 times the square root of 2 winds up being the square root of 6 all over 4. I have a common denominator already, so I'm just going to combine my numerators. And I get the square root of 2 plus the square root of 6 all over 4. And that is my answer. So going forward with all this, you're pretty much, the hardest part is going to be which formula that I need to use. Once you do that, then you have to remember your unit circle. As long as you remember the 5-finger rule, you can do the whole entire unit circle. Okay? So that is it for example 1. We are going to move on to example 2. So I guess I will see you there. TTFN. Ta-ta for now.
All right, welcome back. We are at example 2. So in example 1, I gave you cosine of 15 degrees and told you to find the exact value. And so from there, you're taking that cosine of 15 and we're going to expand it. So now what we're doing is I've already given you the expanded form. What I want you to do now is go backwards and give me what does the actual problem look like, and then answer the question from there. So here's our example. Find the exact value of cosine 80 times cosine 20 plus sine of 80 times sine of 20. We're going to take this and following our formula. The hardest part here is picking out which formula we have to use. And so if you take a look at all your formulas, you will notice that when you have 2 cosines, a plus sign, and 2 sines, that is actually the same thing as cosine of alpha minus beta, because that gives you cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Okay, so looking at this, this is my alpha, and the 20 is going to be my beta. So now it's just a straight plug and chug. So we already have that. So I'm looking for this piece right here. So my alpha is 80, my beta is 20. So I've got cosine of 80 minus 20. That gives me a cosine of 60. And from your unit circle, you should remember that the cosine of 60 is what again? Hopefully you remember it is 1/2. So see why I sat there and drilled the unit circle into you over and over and over again? Because here it is again. We're back at it again, and we're pretty much going to be using it over the next few sections. So if you don't remember the unit circle, get out your chart, get out your circle, Google it, whatever you need to do, but make sure that you have it on hand so that way when you're doing these problems, you're not struggling trying to remember what it is that you need to be able to substitute where. Okay? Example 2 was really short and we have everything that we needed to do. So on to example 3. See you in the future. Ta-ta for now. All right, here we go. Back to example 3. And now what we're going to be doing is everybody's favorite thing to do, verifying. I know I hear all the cheers and the happiness behind your voices right now. So let's just go ahead and jump right into this. So now we are in a section called sum and difference formulas. So that's going to be kind of your big clue of what you're probably going to do first in this section. So I'm looking at my problem here. I've got the left-hand side the left-hand side says cosine of alpha minus beta all over sine alpha cosine beta. And that equals cotangent alpha plus tangent beta. So the biggest thing that's going off right here is that cosine of alpha minus beta. Because we're talking about sum and difference formulas, that's pretty much the side that we're going to use because I can rewrite that. So let's go ahead and do just that. So cosine of alpha minus beta, that is cosine of alpha times cosine of beta, and that's plus sine of alpha sine of beta, and that's going to be all over sine alpha cosine beta. Nope, I don't like that B. Let's try it again. Beta. Nope, don't like that either. One more time. Beta. Beautiful. Okay. Now, from here, you're like, okay, I got this really big ugly fraction. What on earth do I do with this now? Well, you're trying to turn it into cotangent alpha plus tangent of beta. So what we need to do is take this one really big fraction and split it into two separate fractions. Mind you, when you do this, you always keep the denominator as is. So you write everything that's before the plus sign. You're going to write that. So we have cosine of alpha, cosine of beta, all over sine of alpha, cosine of beta, plus sine of alpha, sine of beta, all over sine alpha, cosine of beta. Ooh, that was fun. So now what we need to look at is, okay, I have these two fractions. What should come next? You guessed it. Let's start canceling things. So I have this cosine beta here is going to cancel with that cosine beta there. And this sine of alpha is going to cancel with that sine of alpha. All right, so let's clean this up a little bit and rewrite our leftovers. So we have cosine of alpha all over sine of alpha plus sine of beta all over cosine of beta. Ooh, almost done. What is cosine over sine? That is cotangent of alpha. What is sine over cosine? That is tangent of beta. And look at there. We got what we were looking for. Okay, so when you see these pop up, and I don't think I gave you very many, but when you see these pop up and you see that cosine of alpha minus beta, that's the very first clue. The first thing that you need to do is go here and write down your sum of difference formula, whichever one it gives you. Okay, so without further ado, that is example 3. I hope y'all are enjoying this section. It should be a little bit easier for you moving forward. Nice little break. So there's nothing else. Make sure you're emailing me and everything, and I will see you in example 4. Okay, TTFN. Ta-ta for now. Here we are. We are all back. We are now focusing on example 5. We've got just a few more examples left, and then you get to tackle these all on your own because why? Because you are awesome. All right. So now that you're done rolling your eyes and laughing at me, here we go. Example 4, find the exact value of sine of 7 pi over 12 using the fact that 7 pi over 12 is equal to pi over 3 plus pi over 4. So when you have this type of problem or whatever, and it's going to be a little bit more difficult for you to be able to figure out, all right, I have no idea what I'm supposed to use, they will typically give you the fractions that you need to go with. Unlike an example, I think it was 1 where we had to figure out cosine of 15 degrees, we got to pick what we wanted. Usually here what they do is they actually give you the fractions for you to use because it just makes that a little bit easier for you. Okay, so you now know the some different formulas for sine. So we're going to take a look at using that and taking this problem and solving it for the exact value. So this is exactly like the one in the notes, and I chose to do this one here as well so you can actually see and hear what I'm actually saying when we do this. So they want me to find sine of 7 pi over 12. Well, I know that 7 pi over 12 is that. So I'm going to say sine of pi over 3 plus pi over 4 because when I combine that together, I get the 7 pi over 12. So now I gave you a bunch of formulas in your notes. And so if you take a look at it and you're looking for sine of something plus something, that winds up being sine of alpha cosine of beta plus cosine of alpha sine of beta. So I'm going to take that formula and it's just a plug and chug. So I know that this is my alpha and this is my beta. Not that way. Beta is this way. So going forward, let's plug everything else in it and see what we get. So I wind up with a sine of pi over 3 times cosine of pi over 4 plus, because when your signs are going to match, plus, now instead of sine, we're just going to kind of reverse just the sine and cosine. So we're going to leave our alpha and beta in the same order. We have cosine of pi over 3. Oops, not plus. It's times. One more time. Times sine of pi over 4. So I took the sine of pi over 3 plus pi over 4, plugged it into my formula, and I got that back to the unit circle. See how it all comes back to the unit circle? So now, sine of pi over 3 is the square root of 3 over 2 times cosine of pi over 4 is the square root of 2 over 2 plus cosine of pi over 3 is 1/2 times sine of pi over 4 is the square root of 2 over 2. I'm going to clean this up, and I wind up with the square root of 6 over 4 plus the square root of 2 over 4. I have the same denominator, so I'm just going to go ahead and make my life a little simpler. And I'm going to say the square root of 6 plus the square root of 2 all over 4. And that, my dears, is your final answer. Okay? Hopefully it wasn't too bad for you. I thought it was kind of fun. But then again, I'm a little strange as some of that you have kind of told me over the years. So anyways, I miss y'all all, and I hope everything is going well. If there's nothing else or anything else I can do, then we'll go on to example 5. See you there. TTFN. Ta-ta for now. All right, welcome back. We are in example 5 now. Now, example 5 is going to be kind of long because, as you can see, there's 4 parts to this. Now, I did a different example in the notes for example 5, so you'll have 2 things to look at. So hopefully this will clear things up. So for parts A and B, you're literally going to have to draw it on the coordinate grid and try to find the right triangle, and then you have to remember to use Pythagoras when you're doing this, okay? Pay attention to the directions that it gives you so that when you're in this and you're working these problems, that you're drawing them in the right place, because it will give you all the information that you need. You just need to remember, where does everything go? So here we go. Let's start with A. So we have cosine of alpha is what they want. Well, in order for me to find that, I have to use this piece up here. I have to use this right here because that's going to help me find cosine of alpha. All right. So what we're going to do is the first thing we're going to do is we're going to draw our coordinate grid here. So we've got something that kind of looks like this. Does not have to be exact, just has to be functional. Okay. So now what we're going to do is we are going to change colors here. We are going to now plot this right here. So I've got sine of 12 over 13 is in quadrant 2. So I know I've got something that comes up like that. All right. So I'm somewhere over here. I'm in that vicinity. That works for me. And then once you pick your ending point, you're just going to drop an altitude straight down so that you can form that right triangle. Now, we know that sine means opposite over hypotenuse. So this is my angle in question here. So I've got my opposite is going to be the 12 and my hypotenuse is going to be 13. And what I'm looking for, is my x here. Let's try that again. X. All right. So now, before I can start working on what's cosine of alpha, I've got to figure out what x is first. So when I go through this, I have to use my Pythagorean theorem. And you have to remember, Pythagorean theorem is x squared plus y squared, and that's going to equal your r squared, which is your hypotenuse when we're talking about trigonometry. We don't know what x squared is, so that's just going to sit there and look cute for right now. Our y squared, well, our y is 12 with the squared. And then our r, that's going to be our hypotenuse, because remember, this is my right angle, and so that's going to be my hypotenuse. So my r is going to be 13 squared. Clean this up. So x squared plus 144 is equal to 169. I'm going to move the 144 over. I wind up with x squared is equal to 25. Take the square root of both sides, so my x is equal to plus or minus 5. I say plus or minus 5 because that's a true statement. So now I have to pick which one is it? Is the plus 5 or the minus 5? Well, you have to realize I'm in quadrant 2, which means that this right here is going to be a negative answer. So the x that I'm going to use is x is going to be equal to negative 5. So now when I answer my question for cosine of alpha, my cosine of alpha is, in this case, it's adjacent over hypotenuse. So that means my adjacent is negative 5 and my hypotenuse is 13. Okay. So if we did all that correctly, this is what we have for our cosine of alpha. So I'm going to give you a few moments and I'm going to let you work on part B. All right, here we go. We have worked through part A. So hopefully you've taken the time and you've worked on part B. So let me show you the answer for part B. So again, doing exactly what we did in part A, we went ahead and did our right triangle and we used the Pythagorean theorem and everything else. And then we wound up with cosine of B is equal to 4 over 5. So hopefully everybody did that correctly. Again, if you have questions, please make sure you're emailing me or reminding me or something like that, so that way I can help you walk through it. All right. So now we found part A. We found out what cosine alpha was. In part B, we found out what cosine beta is. So let's jump to parts C and part D. Okay. So with that, this is what we're given and this is what we were found. So hopefully I transposed that right, which I did. Thank you. Okay. So now we have cosine of alpha plus cosine of beta. So if you remember your formulas, so cosine of alpha plus cosine of beta, that is going to equal, don't like that one. Let's try that again. Make it a little darker. That is going to equal cosine of alpha, cosine of beta, minus, because cosines are opposite signs, sine of alpha, sine of beta. From here, it's literally a straight plug and chug. So cosine of alpha is negative 5 over 13. times cosine of beta, which is 4 over, not 15. I was going to write 15, but no, it's 4 over 5. And then we go minus the sine, which is 12 over 13 of alpha, times the sine of beta, which is 3 over 5. Now, key point here, if you can reduce, do not. Because 9 times out of 10, what winds up happening is, if you take a look, you'll notice that you'll wind up with a common denominator already. So as I do this, what I'm going to do is clean up the left-hand side first. And that gives me, what is that? Negative 20 over 65. Yep. Minus 12 times 3 is 36. Again, over 65. And that winds up with negative 56 over 65. Okay, that's it. You're done with that one. There's nothing else to do. So don't try to make it more complicated. Use the stuff that's been given to you and go from there. Okay. Last part, let's look at part D. Sine of alpha plus beta. If you have the opportunity, I would pause the video real quick and see if you can do this on your own. I will give you a few moments and then I will pick back up. So pause it going now. Okay, so hopefully you paused it. So if you did, you should have chosen this piece right here. So sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. Again, another plug and chug because you have all your information. Either you found it or they gave it to you. So your sine of alpha will be 12 over 13 times your cosine of beta, which is 4 over 5, plus your cosine of alpha, which will be negative 5 over 13 times your sine of beta, which will be 3 over 5. So again, don't simplify, even though you can in some places. Don't. Clean this up. You wind up with 48 over 65 plus a negative 15 over 65. And 48 minus 15, was that 33? Over 65. Okay? And that, my dears, is part D. And so that's how you would do a problem that looks like this. Yes, it's pretty long. You got 4 parts. Really, part A and part B are the main two because you have to have the 2 pieces that they gave you, or there are 2 pieces that you're missing. And then C and D is just picking the right formula. Okay? I hope this is going pretty easy for you. It should be. If you have any questions or anything, please make sure you're emailing me. I think we have one more. No, actually, that is it. We are done. So these are all the examples that we have